What is the philosophy of science? Different ones among you might have different attitudes toward philosophy. Some of you might think of it as a very rigorous discipline, logical. Others might think of philosophy as something kind of squishy and wishy-washy. But probably all of you understand science to be very different. Philosophy and science are enormously different enterprises. Why then philosophy of science? What is that? Those are the questions that we're going to be asking ourselves in this first segment. Let me ask you what might make science philosophically interesting. I mean, it's interesting to scientists, but why might Carl?
Investigation of the roots of the universe.
So metaphysics is one of the areas, the traditional areas of philosophy. It is supposed to be investigating the basic nature or roots or foundations of the universe at large. Physics certainly does a good job or it seems to be doing a good job of explaining the nature of the physical universe. So physics is doing a good job at a traditional philosophical task, namely understanding the natural world. And so is biology and chemistry more and more in the 20th century are taking on the same kind of rigor and explanatory power that physics has had for some time. So there's a deep metaphysical interest. What I'm going to stress, though, is a different angle. What I want to stress throughout the quarter is science as a means of just gaining knowledge. Again, physics and the natural sciences will probably be our primary example throughout. But it's interesting also to ask the question, what is it that the social sciences aspire to? I mean, what are they trying to do? Well, they're trying to explain a certain domain of activity. They're trying to understand it. They're trying to gain knowledge about, well, economics is trying to gain knowledge about social economic behavior, and sociology is trying to get some kind of knowledge about the behavior of people in groups. I suppose those are kind of two rough glosses of those subject areas, but that's their point. Their point is to try and gain knowledge. And epistemology, of course, is one of the, with metaphysics, is one of the central disciplines within philosophy. It's the study of knowledge. And so philosophers from before Plato have made distinctions between things that we could really know and things that just appeared to be true or were mere opinion. I mean, what's the difference between the scientist's assertion that the physical world is such and such and my uneducated opinion that the physical world is such and such? Well, the scientist has something or other, one might think, going for him or her. The scientist has something behind his or her assertion that the layperson doesn't necessarily have. It wasn't always possible to distinguish between science and philosophy, because science and philosophy have common roots, but in the modern era, there is such a distinction. There is a difference between, for example, metaphysics and physics. It's sometimes difficult to figure out where you draw that line, but there's a difference between them. Okay, so science seems, physics especially, again, there goes that example again, but science seems to be doing a pretty good job of gaining knowledge. What are some alternatives, though? I mean, is there any other way of gaining knowledge? I mean, any other candidate that we have to choose from if we say, well, science does a good job? You know, that sounds very nice, but as opposed to what? What are other avenues to knowledge?
History.
Pardon me?
History.
History. Is that not? See, that's what. Here we're in one of those puzzling areas. I'm not sure whether history is a science or not. You'd say perhaps not. It's one of those fuzzy. It's not like physics, but people try to approach history scientifically. At least some people would say it that way. So it's anyway. That's one of those fuzzy cases. I don't know what to say about history and whether it's an alternative to science or whether it's just a science, one of the sciences. That's
Not religion?
religion. How about that? I mean, it often seems to at least some of its practitioners to offer an alternative to science, a way of getting to knowledge that is different than and sometimes perhaps even opposed to science. At least another candidate. Again, I think some people would argue with that. Some people in religion and some people in science would argue with that characterization of science as being a competitor of religion.
Drug-induced mysticism.
One claimed way of gaining knowledge might be through hallucinogens, through mind-altering experiences. Within the religious tradition, and here is at least a link between the two things that you suggested, within religious traditions, some of them very old and some of them very new, there are mystical traditions there. One of the things that's sometimes supposed to distinguish science and religion as ways of knowing is that science relies on, we're going to ask ourselves what, but science relies to a certain extent on mathematics, science relies to a certain extent on experimentation, whereas religion is often said to rely on revelation. That's a different kind of avenue for gaining knowledge than is admitted in the sciences. Revelation that is either through some great book, like the Torah, like the Quran, like the Bible, or perhaps revelation as passed along by wise persons. I mean, wise guys? No, by wise men, shamans. You know, these are in the pre-literate and non-literate cultures of the world. There are no great books, but what there are great traditions which are learned rote by the religious leaders of the community and passed along. Or, and here's the link, sometimes the revelation comes directly. Sometimes there is a direct experience of divinity alleged, either by the leaders of the religion or within some religions by practitioners. And you find this in the Christian tradition, great Christian mystics, in the Jewish tradition, great Jewish mystics, in the Islamic tradition, in all of the main ones, in the minor ones. There's a tradition underlying the organized doctrines of the churches. There is reliance on, to some extent or another, the ability of the individual to get into direct touch with divinity, with God. You don't have to go that far. You could go to born-again Christianity, in which the relationship between the person and God is supposed to be direct. No more through churches, no more through priests. The relationship between an individual and his or her God is alleged to be direct. You know Jesus directly. You don't just hear about Jesus and then believe somebody. You have direct experience. And you know that it's God. So I understand. I mean, I have not been in the position where I have received such revelations or known such things in such ways. But if you rely on witnesses, if you rely on people who issue reports through all time and in all cultures, there have been such reports. People are as convinced about these things as they are of anything, and the particular people who are convinced of these things are not characteristically unreliable people. They're often some of the most reliable people around. And among them are scientists, among them are doctors, among them are all kinds of people. It's not like it's just a bunch of uneducated people who feel this way. And this is an avenue to knowledge, to understanding, to truth, which, if it's there, is certainly an alternative to what science offers. I mentioned a moment ago that it's difficult to draw a real sharp line between philosophy and science because they have similar roots, for one thing. Science, in a sense that I suppose we'll touch on in the quarter, science grows out of philosophical efforts to understand the world around us. And it never entirely leaves philosophy. In the 20th century, both Albert Einstein, for example, and Niels Bohr thought of themselves first and foremost as natural philosophers, which is the old word for physics before they had separate departments over there. I mean, the major degree, the highest degree in all of the sciences is what? Yeah, PhD, Doctor of Philosophy. This harks back to a day when there weren't these separate departments. The granting of that highest degree meant, and still means, that the person is capable of dealing with the state-of-the-art questions, the things that are sort of right at the periphery of the field. That's what that degree is supposed to mean. And those are, even to the practitioners, to this day, often considered philosophical questions. I mean, you get disagreements that run on for, well, in this century, you got disagreement between Bohr and Einstein that went on for 30, 40 years about the character of the subatomic world, the world within the structure of the atom. Disagreements, I mean, these are not people who don't know what they're talking about. These are the best experts there are. And they have disagreements about what's going on at that level. They agree across the board on tons and tons of other things, but there is, at this edge, at the state-of-the-art edge of the discipline, there remain philosophical disagreements. The science has perhaps not pushed out that far, has not learned how to handle those things in a way that is generally accepted within the profession of scientists. So those questions remain philosophical. So science hasn't completely gotten away from it. Nevertheless, I think if you looked at the way philosophers dealt with problems and tried to gain understanding, and philosophers pride themselves in trying to reach understanding, and then if you looked at the way that physicists went about their business, working physicists, rather than trying to figure out how do we distinguish these fields in principle, it seems to me that you'd be forced to the conclusion that there are differences between the way philosophers try to gain understanding and the way that working scientists try to gain understanding. Now, what intrigues philosophers is that, about science, and especially about physics, is that given the domain that physicists have chosen, namely, the world of matter-energy, I guess we'd say right now, what it is, how it works, what its structure is, that's the domain that physics looks at. Within that domain, physics, especially over the last 300 years, has been monumentally successful. It has had runaway success compared to any other competitor that anyone can think of concerning the development of knowledge, whatever that means, understanding. I mean, it doesn't mean that physics, no one thinks, I shouldn't say no one, but not many people believe that, that physics has sort of like established the absolute and never-ending truth within its realm, perhaps least of all physicists. But the understanding this year appears to be better than the understanding last year. The understanding in this decade appears to be superior, broader, deeper than the understanding in the decade before. And the understanding in this century appears to be remarkably deeper, broader, better than the understanding in the century before. There seems to be progress here. Whereas progress isn't even a question in that mystical revelatory way of knowing. You get shots of insight with mystical revelation. You don't get arguments that develop. You don't get theories. You don't get systems that can be applied here and there and everywhere. You get revelations, glimpses of truth at best. I mean, that's according to its practitioners. That's not according, I mean, forget about whether it really is insight, which is a very, an open question. I don't mean to beg that question. But, just accepting it for a moment as a possible way of getting some kind of knowledge, even its proponents say that what it gives you is glimpses, insights. Things are revealed to you. Aha! Whoa! Dynamite, far out. I mean, you get these, and they're often ineffable. That's one of the characters of mystical experiences. They're ineffable. Those who took a philosophy of religion course, do you know what ineffable means? Unable to be effed. No, I mean, it means unexpressible. You cannot express them. There's no way of putting the truth that you've just learned into words. I mean, mystical revelations don't come in like this. You shouldn't eat butter. I mean, it doesn't come in like that. It doesn't come in like this. Just plain things like that. It goes, whoa, I see it. That's the way revelations come in, whether they are hallucinatory, generated by drugs, or whether they are religious. They come in such a way as to be unexpressible. That makes them suspect to some of the rest of us who think that you should be able to express what you know or what you understand. But lots of people, perhaps all of us in some issues would say, look, I've got some knowledge that I just am not able to put into words. There are some things I understand that are not easily expressible. Artists are perhaps the best evidence for the fact that truths, or important things anyway, can be expressed that just couldn't be tackled with paragraphs and sentences. Poets, to a certain extent, are again examples of the same sort of thing. And what the mystic claims to get revealed is something that is singular, not something that progresses or regresses. They're truths, shots of truth, and in particular shots of ineffable, inexpressible truth. And philosophy, for all its pretensions, and this is my career and my life, but it seems plain, for better perhaps and for worse, it seems plain that philosophy doesn't really progress. I mean, each generation of philosophers seems to just kind of go back to the same, go back to the basics, try and reestablish foundations under everything, works as far as it can, and then it dies off. And then the next generation comes out and says, nah, and they scrap the whole works, go back to the foundations, work up, scrap the whole thing, go back to the foundations, work up repetitively, very little progress. What's intriguing about science, long story finally coming to a circle, what's intriguing about science is that there does seem to be progress. We do seem to be getting somewhere. That's the way it seems anyway. We'll have occasion in the quarter to examine that claim, to question it, but boy, it sure does seem like science makes progress. That, given that philosophy has always been concerned with knowledge and trying to gain knowledge and trying to gain understanding, that right there is the main reason why philosophers are interested in science, in physics especially. Philosophers are interested in how it is that we come to know, what kind of thing knowledge is interested in distinguishing knowledge from mere apparent truth, is interested in distinguishing knowledge from mere belief. Physics, somehow or another, appears to have developed a method for reliably, repeatedly, at least over long periods of time, getting closer and closer to the truth, or at least weeding out more and more error. In other words, making progress. So that, probably more than anything else, is what interests philosophers, in science. In a way, I think you could probably take a philosophy of science course to be just another name for an epistemology course. A course in, in the study, again, of knowledge. If that's a foreign word to you, you should know it. Epistemology is the study of knowledge, not the study of stems or epistles, letters. It's the study of knowledge. And philosophy of science is just an effort to look at the processes of acquiring knowledge, focusing on those disciplines that seem to have had the most success in acquiring knowledge. Okay, let me open the floor to any comments or questions you might have at this point. I'm not sure that there are any, but there might be. Again, the thesis so far, my argument, or not argument, but my contention so far has been that the main philosophically interesting thing about science is not so much the metaphysics, the angle, where it tells us interesting things about the universe, but more as a process, more as a method for acquiring knowledge. If we could figure out what science had going for it, if we could figure out the core thing that physics does that allows it to be so successful in its realm, maybe we could apply it in some other realm. I mean, look what economics has kind of tried to do that. What's the story of the calculus? Does anyone know about the invention of the calculus? Who invented it? Why? Descartes didn't. It's around the same years, but Isaac Newton invented calculus. If someone else had said, is there any other candidate that you want to mention? Yeah, Leibniz. Leibniz also invented the calculus, quite independently of Newton, and they had a big fight about it. But Newton invented the calculus. Both of them invented the calculus for the same basic reason. Because they're kind of designing a rigorous language, a mathematical language that could take care of, could accommodate, could deal with what each of them thought were the basic truths of the world, the basic truths of the physical world in particular. Now, they both had monumentally different theories, but they're writing at about the same time. They're both influenced by the same developments in science. I mean, you know that, or you may know, you should know, that among other things, Newton is writing in this context. Johannes Kepler has figured out that the rotation of the planets around the sun can't be circles, as Copernicus had it. Even Galileo thought they were circles, that the planets rotated around the sun in circles. We've gotten beyond the older theory, which we're going to come back to and dwell upon at nauseating length, the older Ptolemaic theory that said that the Earth was at the center of everything. We're now in the mid-1600s, and pretty much the scientific community has managed to gain pretty widespread agreement on something like the Copernican theory. Now, Kepler's the fellow who's figured out that it can't be circular orbits, it's got to be ellipses. And Kepler also figured out the mathematical equations that told you just how those planets moved. As any arbitrary planet goes around the sun, it cuts these segments, areas, area 1, area 2, area 3. What Kepler was able to establish was that the planets, as they move, they cut out equal segments in equal times. Now, Galileo had figured out something entirely different. Forget about the planets now. Galileo had figured out how objects move. You remember Galileo? He isn't really the guy that dropped the balls off the Tower of Pisa in Italy and had them land, different mass, big ball, little ball, dropped them off the tower, both hit the ground at the same time. He's not the guy that really did that. He worked with inclined planes. But what he did do was to figure out what the mathematical laws were, laws of motion, that will allow us to tell when we took the ball and put it up here just exactly how far along the incline it would be if we just let it go from this height and let a certain time elapse. He was able to figure out those equations, which you all know very well. It goes on x equals x sub 0 plus v, et cetera, et cetera, et cetera. He was able to figure out those equations. Although he did that all geometrically, by the way. He didn't have algebra yet. Only Descartes, when he came along, his contribution was to give an algebraic interpretation of these geometric things that Galileo had figured out. In other words, he invented analytic geometry, which allows us to express geometric truths in algebraic terms. But here we have, forget about Descartes now, we have Kepler, who's figured out the rules for the movement of the planets. the rules of motion for planets around the sun. We have Galileo apparently doing a completely different science. He's doing motion of physical objects. Kepler's doing astronomy. Galileo figures out the equations of motion that govern such things as cannonballs. You can now calculate just exactly how much powder to put in your cannon to give it the right, and put it at the right tilt to hit the people over there on the other side of the channel, or whatever it is that you're aiming at. So Galileo has figured out this stuff. Kepler has figured out this stuff. What Newton was able to do is to bring all this stuff together to show that the same basic laws of motion apply to the planets in the heavens as apply to the cannonballs on the Earth, and to the marshmallows on the inclined plane on a perfectly marshmallow frictionless surface. But all the laws of motion are the same for all of these things, and Newton was able to figure out what those laws were only because he invented the calculus. So Newton's invention of the calculus was done with a particular end in mind, a particular end to try to explain physical phenomena of motion, whether on the surface of the planet or whether planetary in space. Well, what I'm getting to now, you remember I mentioned economics some time ago. In the 20th century, what economists have done is to take the calculus over bodily as a tool for explaining the movement of money, as a tool for explaining facts in what's called econometrics, trying to explain economic facts about this abstract thing, money, about the gross national product. The calculus is used in that discipline. Now, what would have led anybody to think that you could use something like the calculus in such a, which was designed for this purpose, in such a disparate field? Well, the same motive that I'm ascribing to philosophers in looking at science. The economists, lots of people, but John Maynard Keynes among them, were looking very hard at physics, and they were saying, look, what can we do to improve our understanding of economic affairs, economic matters? Boy, physics sure does a good job over there. I wonder what it is that physics is doing that's got it right. Maybe it's mathematics. Maybe, in particular, the calculus. Let's see if we can borrow that technique, move it over here, and get something like, equivalent or similar success. In the 19th century, we're going to Ernst Mach was a physicist. Comte, whose first name escapes me right now, was someone who invented sociology. But Comte especially thought that sociology should become the new religion in the world, that we should abandon all faith in gods and instead accept faith in science. He thought that societies needed a religion, and for Comte, that religion should be science. And that meant that it would be science that establishes our social goals, science that establishes our policy. And of course, that meant in the 19th century that we really got to work hard to make our study of human societies and our study of human individuals more scientific. Karl Marx, also in the mid-19th century, is famous among academics. Academics who sort of are interested in Marx, whether because they're political fans or just interested in him as a sort of a theorist, are likely to tell you that one of the first people to be dissatisfied with societies like the Soviet Union or China would have been Karl Marx. He would have been one of the gravest opponents of those particular regimes, because they had nothing to do with what he said should happen. In particular, this is a little bit a chapter out of political philosophy, Marx said, you can never force social change. Social change happens when it is ready to happen. You can't have a little clique of intellectuals holding a revolution and changing all of society. That's Leninism. For Marx, you get changes in society when they're ready to happen, and they are driven by changes in the material conditions of production. Enough about that. But he wanted to try and have a theory of scientific socialism that explained just exactly why societies change, why it is that societies move, why it is they progress, why it is they regress. What conditions are they that are required if a society is to make progress in any measurable way? Is there anything that individuals can do? Marx would have said, not really much. I mean, this is just, societies just kind of move and evolve for objective reasons. So what he tried to do is to establish a science of societies. All this movement in the 19th century to try and take something like what was so successful in physics and to apply it to other realms. That's what philosophy of science is all about, trying to figure out what is it that, that physics especially has going for it that we can take away perhaps and apply in new realms. Okay, now let me pause and again ask if there's any comments or questions there. I sort of did a blunt pause, but okay, lean back.
It addresses a lot of things that are more or less, well, like with physics, we've got certain laws, and they've discovered the laws, and they're independent of us. You know, the people around them, like, it doesn't matter how you, well, it matters how you throw the ball, but you can always describe how it's going to work. Whereas psychology or whatever, there's no real laws, well, I guess that we could say that they've discovered yet, that, you know, given A, you know, somebody's always going to do B, or whatever. It just seems like there's not a certain laws of the science yet that they've discovered. Maybe that's the difference between the two fields.
There's a lot of yets there. Are you sort of thinking that, well, at the very least, psychology is young, right?
Years, but yeah. Right now, though, I don't see how there's really, they have these immutable laws.
Could I ask you to make a leap of faith and sort of speculate? Do you think that psychology ever can get to be as rigorous as science as physics?
Probably not, because we've already discovered how we can change a lot of things on our own, just the behavioral end of it. So you could constantly modify, like if you came up with a law that said if somebody sees red, they're going to get mad or whatever. Well, behaviorally enough, I think if you worked at it, you could change it around so that when people saw red, you'd calm them down. Because we just learn how to change people too much.
Let me just make this observation, then go on to the other questions. Progress in science seems to be measured, among other things, by knowing what kind of regularities, or not knowing, but hitting upon the right kind of regularities. There have been, since the dawn of written thinking, since the dawn of writing, you know, way before the pre-Socratics in Greece, so for 3,000 years anyway, there have been there's evidence of speculation about what the basic processes are in the universe and what the basic regularities are. In other words, what the basic laws are. But for motion, I mean, we've got Aristotelian physics and Aristotelian doctrines about motion, which talked about laws of motion. For example, in Aristotelian physics, the reason this goes over there is because it's seeking its natural place. Okay? And it just apparently found it, at least temporarily, unless I remove the floor from under it. But that's what it was doing. This has a lot of impetus in it, too. And so motion is described in Aristotelian physics by impetus within objects as they're thrown, sort of pushing it along. Now, that's not altogether gone in physics. We still have this strange thing which I never understand. I don't know if you remember this from physics courses, but right now, this has got a lot of something or other in it. What is it? Potential energy, right? There it goes, quick, there it goes. It's all gone. No, at least a lot of it's gone, again, until I remove the floor out from under it. But it had a lot of potential energy in it, which was released. Now, that's a funny way of thinking, it seems to me, but it's still taught to this day, as far as I know, in physics books. So that's some of the Aristotelian stuff that's there. Let me make this suggestion about a law of human behavior, not something as simple or on the surface as if somebody sees red, then they get mad, but rather something like this. When any organism, person or other, when any organism is in a state of deprivation among one of its primary needs, food, water, maybe affection. I mean, what the primary needs are things that are still, debatable. but that when any organism is in a state of deprivation and receives some gratification, let's say it's hungry, it gets some food, whenever that happens, it will be more likely, the likelihood is increased that it will repeat whatever behavior it is that preceded. I mean, that's the way you train dogs. I mean, I'm trying to state an abstract principle, but let's say you make your dog really hungry, and let's say what I want to do is to get my dog to sit up. I can't do this successfully, but this is what trainers do, is first of all, they get the dog hungry, and then they just wait and get a bucket of food, but they just sort of wait, and the dog behaves. Animals tend, when they're hungry, start pacing, moving around, jumping up and down, barking, yelling, doing all kinds of things. They want food, and especially if you lock them in a room, which is a good idea, if you're trying to train them, or lock them in an area where they can't get food on their own, they're just going to start behaving. And so you kind of wait for and the dog will have a propensity to be around you because the dog's been fed by you before, so it's not like it's completely random. But you wait for the dog to behave. When the dog begins to do something like what you wanted to do, like it begins to sit up, you feed it. You give it one bit of food. You don't feed it so it's satiated. You give it something. Okay, and then the dog is more likely to repeat that. The dog is not going to be quite so random in its behavior as it was before. It'll still be moving around, bouncing up and down, doing all kinds of things. So you wait until the dog does something a little bit more like what you want it to do, and you feed it. And you continue this process. You do what the trainers and behaviorists call shaping behavior. And you can do this with any old organism. You can do it with an amoeba. You can do it with a damn plant. You can certainly do it with people. Then what you do if you're looking for a law is you'd look for something general like that, abstract. You'd say, all right, the law is going to be whenever I reinforce an organism, a behaving organism, in some continuum where it is in need, it will have a tendency, nothing certain, but it will have a tendency to be more likely to repeat that behavior that immediately preceded the reward than it would otherwise have been. Now, there's a law of behavior that's really quite general. That would be the sort of thing that you'd look for. So, I mean, maybe it's not so unlikely that there could be laws of human behavior, but that they're going to be complicated and maybe pretty abstract.
It's easier to describe physics.
Yeah, it really is. So back anyway to the original discussion here.
Just expanding on what
Oh, yeah.
you're saying right there. Like in the field of quantum mechanics,
Yeah.
if you've got a really small particle, you can't tell exactly where the particle is, but there's a region of probability where you will probably find the particle, and that's what you can draw a parallel to in psychology. If you put red in front of somebody, it is likely that they will get angry, or it is more likely.
Right. So the laws of psychology may be probabilistic rather than deterministic. Okay. Again, we'll be making some of those distinctions further later. So I mean that's good. I mean it's so that we might be able. Interestingly enough, quantum mechanics is as predictive, rigorously predictive a science as anything else in physics. But what it predicts are probability ranges. And it does this with certainty. It will, with certainty, be able to predict, with near absolute certainty, as near absolute as in any other area of physics, will be able to predict you a range within which a certain phenomenon will occur, a range of time and a range of space, whatever. But it can't get you the exact thing, and indeed in quantum physics, there's lots of good reasons to say that the electron doesn't have a particular position. It only has that range, but that gets a little weird. I hope we get there toward the end of the quarter. Yeah.
I was just going to say that there may be a point in time where we have more scientific evidence in regards to biochemistry and as to the reasons for behaviors, just like he was mentioning, and that I think we probably will have some solutions to those problems that are based on that.
Mm-hmm.
If you look at what's happening with gene cloning and all the other stuff we mentioned today.
So in time.
In time, I think it might happen.
I'm surprised I'm not hearing from those who think that, no, there's an in-principle difference here. Here's one.
You're going to run into a paradox. The analogy, the economists, they try to predict what's going to happen tomorrow on Wall Street, and then they publish their predictions, thus screwing them up. What happens to your psychology subjects after you start publishing your psychology textbooks or your sociology textbooks. Like, what happens if I publish a textbook, which in psychology I prove that if 50% of the people live in the city and 50% of the people live in the farmlands, those people who live in the farmlands are going to be happy, but only if that 50% is maintained. My 50-50 ratio is going to get messed up because everybody's going to move out to the farmlands to be happy. You know, you're going to run into a paradox like that because the mind has that capability of taking into account laws and using that as a basis for action.
I think I'm going to give another
Something
quantum mechanics example. Is that right?
perhaps, maybe.
No, what you're doing when you publish your results is adding another uncertainty in the question. It's another thing that's going to move the people. If there's 50% of the people in the farmland and 50% of the people in the city, and the 50% of the people are in the farmlands are happy, then the people are going to move when you publish your information. But that's because you publish your information, not for any other reason.
Let me see if I want to bring this kind of back to the a central move that seems to many to be at the foundations of the success of physics is that it has been able to distance the observer from the observed. It is able to give what are called objective analyses. It sets up objective experimental conditions. It tries to do this. I mean, traditional physics has portrayed the world that it looks at as being, even more than at arm's length. Not sure that's clear, so let me try and go back over it again. Physics is objective, whereas philosophy and religion are sometimes held to be non-objective or subjective, because what the physicist tries to say about the data, about the realm that he's studying, is supposed to be not colored by his interests, not colored by or her goals. The institution of science is set up so as to correct for possibilities of personal bias. So that even if a researcher has some professional interest or private interest that they cannot control, the institution of science is supposed to keep these influences out, to make sure that the descriptions of the realm are objective. And then the whole idea here is what's going on in the physical world is independent of what we think about it, is independent of us. We are examining an independent world. We, the observer, the mind, or the minds that look at that world, we can sort of stand back and try and figure out how the world works apart from us, independently of us, because there are laws of physics that are determiners of what happens out there. They are not affected by us. So this whole ideal of objectivity, the objectivity of the researcher or of research methods, has seemed to be essential throughout the history of physics. Look, though, at anthropology. I mean, we've chosen some other examples, but look at anthropology. How can an anthropologist believe that same thing? I mean, anthropologists study cultures. There are no big cultures that are kind of unaffected. I mean, the anthropologist comes from some culture, and he's studying some other culture. How can he put the culture on, like a petri dish plate and study it? How can the anthropologist study the tribe in question without interfering with it? I mean, you ask it questions. You can't control it either. I mean, what you want to do in an ideal physical experiment is to look at a phenomenon unaffected by anything around it. You want to isolate that phenomenon. Make sure that you know exactly what the variables are that are making one thing or another happen. You want to control those variables. Anthropologists would have a very difficult time doing that with any mainstream culture. So of special interest to anthropologists have been cultures that appear to have been isolated from all other cultures. I mean, they're sort of like, you don't have to be able to, in order to study something, you don't have to be able to put it in a petri dish or manipulate it. I mean, astronomy has been a very successful science, and it's real difficult to put a planet or a star or a galaxy on a petri dish. But still, it's been tough with societies for anthropologists. And so they've thought, boy, it really is great if we could only get a previously unknown culture to work with. You know, in the 20th century, I mean, it's debatable how isolated the societies really have been that have been discovered by anthropologists. I mean, sometimes it's occurred later, boy, these people have been in contact with that tribe over there for years, and they are constantly at McDonald's hanging out. No, no, it's not quite like that. So they found these cultures, and then the anthropologist is faced with this crazy question. Let's say they find a culture that's never been in touch with outside civilization before. I mean, let's say they somehow detect it from the top of a mountain. There it is down in the valley. You know, like you can't imagine, I mean, you can't, how do they study it? With binoculars? Well, you're not going to learn their language. You're not going to learn their customs that way. You're not going to learn what they think about this, that, the other thing. You're not going to learn how they work. I mean, how are you going to learn about this culture? Well, you can go down in there and enter into it. You can enter into it and learn their ways from the inside. But if you do that, you're the very thing you've been trying to protect against. You are the outside influence. Are they going to behave the same when they know they're being studied by some outsider? Hardly. They may worship you. Is it going to be the same culture? Are you going to be able to see really how they operate with one another when you come walking in and here you are, probably different complected, differently dressed, different ways, different language? Their interactions with you, the objective scientists, are going to be different than anything that they've ever done before. How can you see them objectively? How can you study them without interfering with the very phenomenon that you set up? So sometimes some people would say you cannot have the same degree of objectivity in the social sciences as you have with physics because you inevitably interfere with the phenomenon. And then in the 20th century, as we'll see later in the quarter, physics fell to the same argument. At the quantum level, in quantum mechanics, you cannot talk about you cannot measure or look at or investigate anything that goes on in the quantum domain without radically interfering with it. Science is philosophically interesting because it's so successful. Philosophers want to know, what does science have going for it? Possibly just out of curiosity about understanding knowledge. That's a classic part of philosophy, after all. But also, perhaps, and in many instances, they're interested in trying to figure out how to apply whatever it is that physics, say, has going for it somewhere else. What we need to do now, though, is to look at some specific proposals about just what it is that science has going for it.